This is your second 3D modeling assignment. But the first thing to do here is to review the geometry of the part and determine which is the most suitable 3D modeling tool to complete the main body. The dimensions of this part are shown in the 3D technical drawing here. This is displayed in third angle projection. It helps you to visualize and understand each feature's geometry. So during this lecture, I will demonstrate a method and selection of tools to model this part. It is recommended to pause the lecture here and attempt modeling this part yourself, and then once completed, you can continue watching the video to see one modeling method which I will demonstrate. So if you could pause the video here and have a go at modeling this part yourself. Okay, welcome back. I hope you got along well with modeling this part, and now I will give a demonstration of one way in which we can model this part here. So let's go on and create a new sketch, and I'm going to sketch this on the XZ plane. I'm going to use the Revolve tool for this. We could do this using the extrusion tool, but it would be much more time consuming and easier to edit and sketch using the Revolve tool. So let's start off with the line tool then. I'm going to draw in our revolution line. Then make that, let's say 100 mil for now. I got a construction line. Good, move that dimension out of the way. Turn off construction line. Hit L on the keyboard again. I'm going to roughly draw in this geometry. I'm not going to dimension it up for the time being and fine tune it a bit later. So we come across, we come up, come back to the right, go up, across, down, and then we're coming in a bit of a recess. We're going down again. So let's constrain and dimension this spot here. First of all, this line needs to be vertical. So use the vertical constraint, apply that. That's now vertical. I need a horizontal constraint between the origin and this point here. Horizontal constraint, this point, origin. Now we're going to start dimensioning. So let's dimension this point here from the origin. And as for the drawing, we can see that we've got a 50 mil inner diameter below that recess. We need to divide that by 2, so put in 25. And then from the outer point here to the center point here, we have a dimension of 200 divided by 2, so 100 mil. We've got a wall height here of 10 mil. Put that in, 10 mil. We've got a distance from this line to the origin, and that is 100 divided by 2, so 50. And then we can do this line to the origin, which is 58 divided by 2, so 29. And then we need to assign a length here. So this vertical line is 50 minus 10, so that's 40. And then the same for this line here. So this line is 30 mil. Okay, that should be fully constrained. If we open up our sketches, yeah, we see the padlock there, fully constrained and ready to revolve. We can finish the sketch there. We're back on the home view. Come up to the Revolve tool, select that. Fusion has selected the profile already. It's the only one available. We just need now to identify the axis. I'll use the construction line here. Hey, preview's looking good. We've got our recess in there, looking nice. Let's press OK. One thing we could have done in the sketch is to implement the chamfers on this edge, and this edge. I'd much prefer to do this in 3D modeling mode as opposed to 2D sketching. Let's come up to the modification tools, go on chamfer. And here we've got all chamfers are 4 mil by 45 degrees. So they are equal distance chamfers. I'm going to select this edge here, this edge, and this edge. And I'm going to input here 4 mil. Okay. Looking nice. And now the only two features left are the series of counterbore holes around this face, and then the series of simple threaded holes around this face. Let's do the counterbores first then. Hit C on the keyboard, select this face. And for these counterbore holes, we've got a total of 12. So we need to input our points in a pitch circle diameter, 12 of those, which will then use the hole tool in 3D modeling tools. So let's start with the circle tool then, and I'm going to input a construction line. It'll be a circle, in fact, and that's going to be our pitch circle diameter. So put 150 mil there, and we know that our 12 circles are distance equally around this PCD, pitch circle diameter. Remove that dimension slightly. Let's go ahead and add a point then. I'm going to create, add a point. We're going to snap that on so it's coincident with the PCD. They're going to use the vertical constraint from the point to the origin. Now that's fully constrained, can't move anywhere. Let's now come under create, You're on the circular pattern. And we are in a circular pattern, this point, around the center point, which is the origin. And in terms of instances for the quantity, we have a total of 12 holes. Okay, preview looks good, the splash is okay. But this is the center point of all the holes we'll make. Finish the sketch there. Come over to the hole tool. In terms of placement, so we got multi-holes. We'll select that. We need to identify our sketch points. Let's go for these four. Sorry, these five, and these two. So we've selected our 12 holes. These are countable. So I'm going to set countable when they are threaded. We've got an N8 thread, and which are active selected. They're fully threaded and drill point. And with an angle, we can go for flat actually because they're through holes, so it doesn't matter which one. Oh, depth, yeah, well, that's through, so we could leave it as the 25, but I'm just going to go with the thickness of this plate here, which is 10 mil. And the counterbore diameter, as per the drawing, is 14 mil, so leave that as 14. And the depth of the counterbore is 4. And then as we come down, we need size, so yeah, it's a size 8, an M8, make sure we're 8 selected. Make sure the designation is correct, so 1.25 mil pitch thread. Okay, 6H right hand. Yeah, let's look at the preview then. Looking nice. Okay. Select OK. There we have our 12 countable holes. One more feature to add then, which is exactly the same process for this face here. But these are simple threaded holes. I press C on the keyboard, select this face. I see on the keyboard again for the circle tool, start of the origin. This has a PCD, pitch circle diameter, 75 mil, press enter. I'm going to select that circle at a construction line with that dimension. I want to create, put in a point, snap that to the PCD, same process, vertical to the origin. I want to create circular pattern, point there, center point, and view the origin here. And in total here, we've got 6 holes as per the drawing. Got our 6 points there. Okay. Finish the sketch. I went to the hole tool. Again, we're going to choose placement multi-holes. Choose our points. Let's go for these 3 and these 3. These are simple holes. When the hole type, we want simple. They do have an assigned distance here, which is 25 mil deep. Okay. They are tamped. They've got an M8 by 1.25 mil pitch thread. Holes to be fully threaded, and the drill point in this case will go at an angle. So let's put the depth in here then with a 25 mil. We'll come down to the bottom and make sure we've got 8 mil selected. The correct designation to 1.25 mil pitch thread. 6H right hand. Have a look at the preview. Looking good, coming down 25 mil. Okay. And there we have our completed part. That's looking good, but I just want to do an inspection on that, do a section analysis, and let's do our section analysis on the XZ plane. Let's go that direction. Everything here is looking good. Yeah, that's looking fine. Our chamfers in there, counterbores. 25 mil simple threaded holes. Yeah, that's looking good to me. Okay, and I select all right there. Back to the home view. I'll turn off that section analysis. But that's one way in which we can model this part. Again, it could be done with the extrusion tool, but much more efficient and easier to control with the Revolve tool. I hope you got along well with that assignment. And again, any questions, please send me a message. I'll reply as soon as I can. And aside from that, I will see you in the next assignment.